Okay, this is the second part of the video lecture for Math 110 for Friday, April 17th. And in part one, we did a quick little chart and derivation of the formula for a compound interest investment. Now, that all said, don't worry too much about memorizing what we did in the previous video lecture. Here's the important thing. This is an equation for the future value of a compound interest investment. It looks a little different than the equation we got, and I want to explain what's going on. This is the equation we want to use for any problem we would do that I give you guys in the homework or a test. Okay, so what this says is the future value of an account in year t. Instead of using n for years, I just use t for years. So the future value of an account is equal to, in year t, is equal to the principal times 1 plus r over m to the mt power. What's happening here? Okay, the added feature here is this m. What m is the number of compoundings per year. So in the previous example, every year we reinvested our interest earnings, and then we earned additional interest on that. Compounding means how often do you reinvest your interest earnings? You could reinvest them after every year. At the end of the year, you say, I've earned this much, I'm putting it back in the account, and now I'm going to earn interest on that additional interest I just invested. But you could actually compound more frequently. You could compound twice a year. You could compound quarterly, which means 4 times a year. You could compound monthly, which means 12 times a year. If you compounded monthly, m would be equal to 12 because m is the number of compoundings per year. You could compound every day, in which case m would be 365. So this is really the holy grail of the formula we want to use to do any kind of example problems we would do. Now let me do one example problem with you guys. Okay, so let's suppose you guys have an investment. You initially invest $15,000 in an account that has an interest rate of 8%. And what we want to do here is we want to figure out, and let's say we compound 4 times a year. So we're going to compound quarterly. Quarterly compounding. And in part A here, we want to figure out what is the account worth in 10 years. So what's the value in 10 years? Okay. What's the value in 10 years? We're going to use this formula. So let's write down some things. If we invest $15,000, our principal is $15,000. Okay. The rate is 0.08 because it's 8%, but we convert that to a decimal. Okay. M is the number of compoundings per year. How many times do we reinvest this money per year? Well, since we have quarterly compounding, that means M is 4 times a year. Okay. And then now t in this case is 10 because we're interested in the value of the account in 10 years. So now the future value of my account, A10, the value in the 10th year, after 10 years, is equal to 15,000 times 1 plus my rate, which is 0.08, divided by m, which is 4, raised to the 4 times t, which is 10. Okay, I'm just plugging in numbers. Let's simplify this. This is 15,000. Okay, this is 1 plus 0.08 divided by 4 is 0.02. 4 times 10 is 40. Okay, and the A10 comes out to 15,000. Now we can add the 1 plus the 0.02, so this gives us 1.02 raised to the 40 power. Okay, and if we plug this in our calculator, we get $33,000. $33,120. This is the value of our account after 10 years. Okay, we're basically using this formula. So be sure you guys are comfortable using this formula and understand what M is. It's a number of compoundings per year. Let's do a second part. How long does it take to triple? How long to triple in value? How long does it take this account to triple in value? So I'm going to use this formula again. Now, if the account triples in value, that means the future value, A sub t, is going to be 3 times $15,000. Okay, it's going to be 3 times $15,000, which is $45,000. Okay, so I can plug in $45,000 for my future value AT. Now I know the principal is $15,000, and then I have 1 plus my rate, which is 0.08 divided by 4. M is 4 compoundings per year. Now I have 4 for M up here, and then, but now here's the thing, T, I don't know T. I'm trying to find T. I want to find how long does it take this account to triple in value. So this is my starting equation. If we simplify this, we get 15,000. I'm going to add these two together. We did this in the previous problem. This is just 1.02 to the 4t power. And this all equals 45,000. We want to solve this equation for t. Okay, this is the same equation you guys have seen for the last 2 weeks. Okay, this is an exponential equation. The way we're going to solve it is we first divide both sides by 15,000. And this leaves us with these cancel out. This equals 3. So we get 3 equals 1.02 to the 4t power. And hopefully you guys see by now, I've done this enough times, the way to solve this equation is take a natural log of both sides. So we get natural log of 3 equals natural log of 1.02 to the 4t power. And we can now bring this power, as we always do, bring this power in front. So this equals 4t times natural log of 1.02. I can now divide both sides of this equation by 4. So now I get natural log of 3 divided by 4 equals t times natural log of 1.02. And then the final step is to divide both sides again by natural log of 1.02. So I'm going to divide this whole thing by natural log. I'm running out of room. 1.02, and this leads to this. T equals natural log of 3 divided by 4 times natural log of 1.02. Okay, so this is the standard way we solve this equation. And if you guys plug in your calculator, you get 13.9 years. So 13.9 years, it'll take 13.9 years for this account to triple in value. Okay, this is a good practice problem for compound interest using this formula. If you guys have questions, which I'm guessing you might have questions in the second part, then tune in on Friday and we'll do another practice problem to get familiar with this. All right, see you then.